printed, I think it's V8 or V7 of the adapter to get the right spot for between camera and fisheye optic, and so we are getting close. Yeah. And hopefully we will succeed with this next week. So that we then have an adapter like this one for the enclosure where we mount camera and optic. Yeah. So that's the status on this. Yeah, I just wanted to show you that you know where we are.
Okay, thank you, Oliver. I've just started recording. Normally I say, welcome to the developers meeting. Oliver shut us off.
Sorry.
No worries. You say you have to leave in 1 hour. So, okay, let's do this.
The latest.
The latest, yeah. Okay. And we should include you in our ethics discussion as well. So let's keep the developer meeting very short. Let's say half an hour, if you all agree. Is this okay with you?
Yeah, but I can step in when I'm at home again. So normally the developer meetings last longer than expected. So I would step in afterwards when I'm at home.
Okay, I have just 5 minutes left. I just wanted to be here for the introduction, and we discussed something with the NUC 10. This is this board for developing, and we did that already. So we have time for another thing. I have to take care of something that I have an appointment, and I can't skip that.
Okay, well, I only have 4 minutes, so no, I'm just kidding.
So, your turn, Tommy.
No, really,
we talk
guys.
That fast?
Be honest.
Hey, sorry, stop, guys, please.
Be honest. You have date, buddy.
Okay. Hey guys, there are some topics we have to discuss. We have to run through. We do the ethics discussion. Let's say we start in half an hour. So we have 1/2 hour, and I want to run through things that are important. Okay, so bear with me if it's not that funny for now. Okay.
Can I quickly? Sorry, quickly, Richard. Just before we start, I'd like to give you guys a demo on something as well. Okay.
Yes, absolutely.
So please, okay.
Yes, absolutely. Okay. But some organizational topics that are important. 2 minutes, okay? So you all got hardware now, okay? And this hardware is either and or camera and optic, and Orange Pis are about to come, and we had 2 NUCs. So there is hardware either on your way in a couple of weeks, let's say the Pis, but you already received hardware. For the ones who received hardware as developers, we are keeping this hardware in the possession of the organization, and the organization lends this hardware to you. Okay, this is it is given in custody. Okay, you use it for development. You do whatever you do with it. It is about to take care of it, but it is not about to not destroy it, because we know development sometimes needs something to be tested, and by that it can be destroyed. So no worries about this. We just ask you to just keep a good eye on it. And whenever you decide to leave the community, our community, then to return it back so that we can give it to someone else. And for this, we set up a drive folder. I will post in the Hangout the link to that folder so that you can first of all see the list of all developers or all people, even testers, who received what hardware, so you can find yourself in that list and see what hardware you are listed with. And then there is a file, it's an agreement that you download. It's a PDF file that you download, that you read, and that you fill in your name, sign, and send back. And send back is just you drop it in the drive folder. Okay, there's a bucket where you just drop it in. We have to do it this way. It's because we're spending money and this money is registered because we take it in, we cannot take it as black money, you know. We do not dealing with black money. All money that's going in and out is official money. We have to keep it in the books, and also to, when we take hardware and we give it to someone, which is quite logic in our case, then we should have a list that we're obliged to curate, right?
Yeah.
So this okay.
May I mention to step into this? I drafted the agreement, and I think you will find it pretty clear and harmless. Yeah. So if there are any questions then to this, please refer to me, and we can then discuss it. Okay.
Okay. So we create this PDF file. It's still in the work, and when we're done, we drop the link in the Hangout. Yeah, second thing that's important from organizational part is that on the 3rd to the 5th of February, so it's about 10 days from now, there's a virtual UAP Symposium, and Sky360 is taking part in, meaning it's a virtual one. It takes 3 days, the 3rd, the 4th, and the 5th of February. The time frame is from 2 p.m. to 10 p.m. UTC. When you go to the website, you see the time in EST, but yeah, I give it to you in UTC, which is, I think, better. So this implies that we have to be present there. So it's like a virtual booth we're running there. There's a symposium. It's about speeches that are held. People attend speeches, and people attend these virtual booths. And the thing is that people come with questions to it. What are you doing? And we have to tell them what we're doing, and yeah, give them some kind of a Q&A. Mm-hmm. And we are now, I think, 6 people helping out during this time frame. And you know, this time frame is 3 times 8 hours, so 24 hours we have to cover somehow. The more people help, the better. So if you have within this time frame time that you can share in this virtual environment, first of all, you won't be probably not alone. We will be either 1 or 2 or maybe even 3 people at the same time there. So please drop me a line in a DM or so when you consider helping out, and I will just then take your email address and put it into the account at the symposium, and then you will get emails with the links so that you can participate in.
Can you supply us with like a PDF so everybody can have like a PDF? What we know what we're doing, but like everybody can be on the same page, something like that.
Yeah, time-wise.
Is that really necessary? I mean,
just asking.
Yeah, I know what you mean. But first of all, we have the website that more or less says it all. If there's something wrong, please tell me. We change it. But you all know.
Okay.
I mean,
I think it will be more of a friendly chat with people coming in and interested in what we are doing, and so if there are any questions, especially for example, for development questions, maybe some other guys here who can answer it, or we can forward them to our website. So I think it's much more of a friendly chat with interested people.
Yeah, true.
So, okay. And Richard, I'd be happy to help. I'll just have to check the days.
Perfect. Thank you, Michael. When anyone of you who wants to help out, please drop me a DM with the time frames you can help. So, Michael, please drop me a DM when you know on what day or days, at what hour and hours you would be able to help out. Perfect.
Yeah, should be pretty much most of them, but let me check that before I commit to it. So.
All right. Okay, and I think to give Idle the last word on the question about the Nix OS update, did it happen yet, or do we still have to wait?
Yeah, it happened, but there is an issue in Nix.
Oh dear.
Done a bigger hole right now. So in Linux, there are two libraries for binaries. There is bin and sbin. Sbin is used for superuser, like root, right? And because fxload is changing or writing to USB, it's a superuser that requires to run it. So, silly me, I put it in the sbin directory. But in Nix, they don't really copy the sbin, or there is a very specific way to do that. So I'm going to make a change to just put it in the bin. That's actually what my Nix mentor kind of told me. So I'll do that probably later today.
Cool.
Yeah.
All right.
Yeah.
Yeah. Okay. So.
But again, the binary is there. It's just not on the path right
true.
now.
Okay.
Yeah.
Okay. Good. So I think one more week to wait, something like this. Probably.
Yes. Now I'm starting to play with to see if I really can use just fxload and the camera firmware rather than install the entire SDK. So I'm going to play with that. If that's the case, then I can move further even more. But besides that, I spoke with Christian this week. I'm going to stop with all the indie server. It's just slowing me down. It just crashes too much because I don't know how to operate the camera. It has all this kind of scientific parameters, and I'm just playing with everything, and I crash it. So I'll build a driver in probably like C++, and Fabrice, if you can help with that, that will be appreciated. I'm not an expert on C++. But I think at this time I know enough to kind of implement it in a loop and kind of broadcast the data on ROS2. The problem that we will have is that even on 1 gigabit network, it's too much data. Okay, it looks like even if it's compressed, it's too much data. So there are a few ways to do that. Just keeping the channel busy with all the data that I can put, it's the wrong way to go, okay? Because that means that I'm not leaving any room for any messages from the robotic system, okay? So those are limits that I'm playing with. See, like what is good enough, but it looks like right now we will not be able to achieve the 19 frames per second. Okay.
Okay. But what you could do is simple things like cropping. I mean, not take the whole stream, but just crop it to the square that's needed. Or maybe even rescale it just to make it work.
Well,
and then wait
look,
for...
if we're running the tracker on the same system as the camera, then it should be fine, right? But then that system is going to be, like even the NUC won't be enough, okay? Because you need like a GPU, okay? We'll find a way. I'm familiar with these issues. The system limitation is exactly what we need. So again, to start, I will limit the frame per second. Okay, that's the easiest. I can ensure, data bitrate that is enough, for the other messages. Okay, and later on we will improve that. And there are really two ways to deal with that. Either we create a separate bus for like audio, video, radar, that it's just like a streaming data, that it's like, let's say 10 gigabit or whatever, okay? And then we leave the 1 gigabit for like messages, or we find something even more unique. I'm playing with a bunch of ideas right now.
Okay.
Okay?
Yeah. So I think you potentially will be constrained by the tracker as well. So I think at some point I'm not entirely sure we're going to be able to process at that volume. So so my view is I don't think you're going to have to worry too much about that. I think we'll have to throttle on your side anyway in order for the tracker to process quick enough. So I wouldn't be too overly concerned about that at the moment. Sort
I
of thing.
think we have to discuss two lanes here. One lane is that Ida was talking about, connecting with a driver that he created or took and changed and used that. And the other route is that Christian is taking via Indie and own Indie protocol using and firmware uploading and what have you. The good thing is what Christian is doing, you can create the stream. You create the stream because he's on the firmware. So he creates the stream with, let's say, even with background subtracted stream, which is rather reduced to only moving parts in the view, for example. That should reduce the stream significantly.
He will not have. Okay. I can't speak for Christian, but what I spoke with him about, okay? Okay. You have even more limitation running as a firmware on the camera itself, okay? It's very, very limited. Mm-hmm. So the idea was, because we are now dealing with raw data, which is not even a picture, right? We are dealing with, I believe it's 4 channels, 16 bit per channel, right? So this is really like electron counts. Then we can create a background subtraction on the electron counts level, mm-hmm. and can normalize it, okay? That should be okay, okay? But a normal background subtraction, as you think of it, probably will not work. Too much computational power.
Can I just talk here just a second? The image from the camera, it's a mono image, okay? It's not 4 channels. It's just 1 channel, 16 bits, and we apply the Bayer pattern. We don't have 4 channels. It's just 1 channel, 16 bits, and then we convert it to color using the Bayer pattern. It doesn't supply the 4 channel unless we ask it to. So it will convert the mono image using the Bayer pattern and then supply us 4 channels, 16 bits. But that's an extrapolation. It generates a lot more data. And we don't need that. We don't need just the basic mono image. We know the Bayer pattern. Then we can apply the Bayer pattern later in the code to create the color image. And that reduces the data a lot. That's what I'm doing with my camera here with the QHY. I'm getting the raw data, the raw 16-bit data from the camera, and then I process it as mono image, and then I convert. I apply the Bayer pattern to create the color image because I know the Bayer pattern from the camera.
Oh yeah.
So
okay.
I know. So that's the way. I only get like the frame as mono image. So it's just one. It's just one channel, and it's much less data than asking for the camera to create me the color image. Then it will generate a lot more data because it will apply 3 channels times the full resolution.
Yeah. Okay. Now your raw image is 16 bits.
My raw image is 16 bits mono. So I just get the 16-bit mono, and then I apply the Bayer pattern later in my code to create the color image. But I don't need the color image from the camera.
Yeah. Okay.
Okay. We can discuss that later. It's pretty easy. It's pretty strange.
So I work reverse. I first hammer it. I see what the limit is, and then I go backwards and see what.
Okay.
Yeah. Okay.
Yeah, you're coming from 2 sides. Somewhere you have to meet. So what Christian is actually doing is on the firmware. He does not. We shouldn't call it background subtractor on the firmware, but because it's something like flat field and back field and black field or whatever these topics are called, and he's doing this on the firmware already. So I think with a proper, and what he's still missing is this FX load upload automatism kind of, right? That's still not properly working, right?
Automation.
There's automation, yeah. So, but I think to have control in the firmware to create these flat or whatever they are called fields and putting them out are already a reduced camera stream, or is already a reduced camera stream. For example, if you reduce it with the background noise of the camera itself, it reduces the stream significantly, because the sky blue is then a shade of and not sparkled with a lot of. So I want to say is, with this implemented, then the stream will be strongly reduced compared to a raw stream now. At least Christian tells so. You know what I'm talking about? Or?
Yeah. No,
Yeah, I don't know, man, because it's digital data, isn't it? So if you've got a I'm really confused by that statement, to be fair, but I don't want to get. I suppose it's not the right place to get into it, but
Mike, it's simple. Like Fabio said, the camera is just producing photon counters. So you get an array, the size of the sensor, and the other axis is the number of electrons counted during a time period, during the exposure time, for example. And then it is converted into something visual. But it is so big of numbers and 16-bit that you can either work directly with like Fabio said, with a background subtractor on it, or you apply something what Christian is doing in the firmware to get these fields. It's actually images. You can get a light field, which is what we call a normal camera image. Then you get the back field, which is with zero exposure. So you get the electronics, the fluctuations of the sensor. And you reduce this. And by reducing this, you reduce the amount of data per frame. So the end of the outcome.
Yeah, but that's.
But that doesn't impact the image size. Okay.
No, it doesn't impact the image size. No.
Yeah, and we have
it just removes the error.
Okay. Oh, okay.
Like we have a problem with the image size. If you saw, like,
I thought the stream. Sorry.
Okay. No, we are exceeding 1 gigabit. Okay, that's the end of it. Okay, so the only thing to deal with it really is reducing the frame per second. Okay, or create a bus that is higher that you can pass all this data. Those are like the main two things. Okay, we can try cut corners, reduce the resolution a bit and stuff like that. But again, I'm thinking here about the authenticity of the data, so I'd rather not touch it.
Yeah.
Right.
Yeah.
So I'll speak more with Christian and see what we can do.
Definitely.
But this is yeah.
When I give you guys my demo, you'll see the issues that I've got concerns with.
Perfectly. Okay. Actually, go ahead, Mike.
Sorry, my mouse is playing. Oh, come on. Let me know when you can see, and then I'll show, and I'll talk you guys through.
Yeah, I can see myself.
Yeah, sorry, my mouse is. I got a wireless mouse, and every now and then it. Yeah. So okay, so I've spent a couple of quite a few hours on this, but I kind of wanted to show you guys where I've got to with this whole idea of test data and synthetic. Well, running simulations with some synthetic data. There's not quite at the level that Matt is suggesting. These are just like really simple tests. So I'm going to run it quickly, and then I can kind of go into a bit more detail if I need to. So so basically, yeah, so you can see it's just a pure white background and then just some information about the actual simulation. So at the bottom, this is the image resolution. And the idea being that it's a really quick visual just to determine if we've made a change, then what sort of impact that has, and is it better or is it worse? Visually, I do still want to include metrics into this, but yeah, I've kind of just got it to this point. But so this is essentially the drone data that I captured. So this, for example, is the drone data as well as the plane data that I captured. So the resolution is still at the lower bit of description just explains the resolution that the image is running at. And then, so once this simulation is run, we'll then like move on to we'll get progressively more difficult, I suppose, or the image resolution will increase. So here we can see the resolution is running at 2160 by 2160, and you can see the impact having on the tracking. I think I have found a couple of bugs that I need to have a chat with Fabio about, but yeah, this is just I think it's a really simple way of just evaluating changes. And then I also just want to just quickly just show how these things are defined. I mean, you can probably see the code in the background anyway. Yeah, so this is basically now we processing, and so this is where I get a bit of a problem with the background subtractor. I'm getting size validation issues with actual bounding boxes and that sort of thing. So the bounding box that it's trying to create is too big. So I've put like a limit on the size of the bounding box. So there's some work but I guess the point I'm trying to make is this is a really easy way to examine the impact of a change. And I think it's just the mechanism is quite straightforward. So I'll show you I'll show the API a little bit, but I just kind of wanted to show you the challenges currently that are happening at 3600 by 3600 in size. And then so once that finishes, I'll just, and it's really easy. So the idea behind this was to try and make it really easy to define additional of these simulation things. I kind of wanted the ability to define these simulation things quite simply, and this basically is the line of code that's required to define a simulation. So like, for example, if we want to, so here we've got a simulation test case, which includes two simulation tests. One uses drone synthetic data, the other one uses plane synthetic data. We specify the target object diameter, and don't worry too much, the loop just means we play it in a loop. And then we also specify the size of the image that we want it to be. I then in code just create essentially a white frame, and I scale. So when I captured this synthetic data, it was on a specific frame size. So what I do is I just scale that up to frame size and then just draw the target object around the screen at a certain frame rate. But the idea being that it's really like, for example, if I wanted to not do drone and plane and just do a drone and a plane, and I wanted to increase the target object diameter of the plane a little bit bigger, then it's really it's quite a trivial way to then make the change and rerun the test. So we're running two test cases now. One basically is the test case that replays the drone data that I captured, and then this will be followed by a test case that replays the plane data that I captured. One thing I would like to explore now is writing a mechanism to capture additional tracks so that we can design flight paths or flight tracks, or I don't know, whatever you want to call them, that we can then use to essentially plug into this mechanism, and in doing so create more challenging simulations as and when we require them. But yeah, so essentially, so yeah, I'm sure you kind of get the idea. So that's basically the demo I wanted to give. So I'll stop sharing my screen now, unless there are any questions. You guys want me to go
And
any?
what is the hardware you're running on?
So I've got a i9. It's a 99K or 9900K or something.
Okay.
It's a yeah.
And so you're not using GPU on this one?
No, there's no. I've not enabled. No, I've not got no GPU enabled on here at all.
Okay.
There are certain things that I could potentially run on GPU, but from a tracking standpoint and the background subtractor and all that sort of stuff, none of that is enabled for GPU. So no, I'm not running on GPU.
Okay.
But this yeah, sorry. And that's sort of the demo I wanted to give, really. Okay. So I just kind of want to make it really straightforward to be able to create these, to evaluate changes to the tracker and make the frames so we can easily scale the frames and increase the complexity of the test. So essentially we can run we can have one test that has the drone and the plane and potential others that we define. Eventually, hopefully drive this via config file versus code. But yeah, just a simple way to evaluate stuff.
And your idea is also to have a different background, not only the white one.
Yeah, so what I wouldn't mind doing is I would like to integrate the playing of a video in a loop, so that we play a video with clouds moving by, for example, and then we also overlay our test cases on that. But I kind of feel that's probably only feasible once the track is in a situation where it can track accurately, consistently, with no background movement at all, just purely the dot floating around. And I think one thing this has highlighted to me now is it struggles on larger frames. And it's not just necessarily the tracker, it's the communication. It's the whole ROS, it's the communication and all that sort of stuff. There's stuff that I need to tweak and look into quite a bit in order to get that to work properly.
One of the things that I did here, because since I have a clear view from the sky here, I put it in the camera and I try the background subtractors in different scenarios here, because I can see a lot of planes from where I am, because I'm in Barcelona, so we have a lot of planes crossing the sky here. And I had a lot of problems with the background subtractor picking up the planes with the trail. It does not.
Yeah,
It just considers it as background, even though the plane is moving and it's generating a trail. And sometimes when there's a lot of clouds and there's something moving, so we'll have to figure out some good parameters for the background subtractor, because sometimes it just does not pick it.
Yeah, I mean, I've experienced that I agree with you. I've experienced that just with that dot moving around, on a
Yeah, because
white background. Yeah. So
yeah,
there's definitely some work that needs needs doing there.
yeah, because I'm using the real time camera from displaying from a window here, and so I'm starting to get some trouble, but I will figure out later what parameters to
Yeah.
use or anything like that.
But that's good though. At least we kind of we are running into these now, which is a
Yeah,
good
sure.
thing.
Mm-hmm.
Yeah, of course.
Yep. Hey, cool. Thank you, Mike. Thanks for showing us.
That was
Incredible.
great.
I think that the 3600, is this a scaling problem with ROS or?
Yeah. So one thing those tests are running at 20 frames a second, and I think there's several things that are going on there, which I think is contributing to this. One of it is I'm having to render that annotated frame. So, I'm having to essentially
Draw it.
in a loop draw the trail. There's lots of, and I think that could be done faster because I'm using Python and it's, kind of not nearly as quick as C++. And so I think I've also, what I've seen is, I mean, one of those, one of those nodes, after I've run my test, is consuming 1.5 gigabytes of memory.
Okay.
So yeah. So I'm gonna have to spend a little bit of time and see why that is and why it's not dropping back down and these sorts of things. So and I'm really happy that this sort of stuff has been highlighted now because it's a really easy way to highlight these sorts of things now. Because in the past I've had to kind of try and find a video and all this sort of stuff. Where now it's really easy to just go, we want to make a frame 5,000 by 5,000 or whatever. It's really easy to do that, and that's highlighting some stuff now. So yeah, it's just I just wanted to show you guys really.
Yeah, cool.
Cool.
Good stuff to Michael. Thank you very much
So,
for
so
showing us.
what version of ROS are you running?
Humble.
Okay.
Yeah. So I don't have any QoS defined at the moment.
Yeah, that's why.
Yeah. So I do still need to like knuckle down and get back into that a bit. So I need to redefine the QoS stuff. I essentially had QoS defined before, but I took it out when I included the filter to essentially filter 4 or 5 messages from different topics into a single message stream to then process it as a single message, because I get like the image and the tracking data and the projection data and all this sort of stuff separately, and then that has to basically get funneled into a single stream that I can then work on. So when I was trying to get my head around all that stuff, I took the QoS out because that was just an additional complexity. So now that I know all that other stuff is working, I need to reintroduce the QoS. But the thing is, there's also the ability now to actually see the impact it has, because I can run these tests and I can see what impact the QoS definition has on the series of tests. Whereas before I
Yes.
couldn't. It was a bit of a, is it better? Is it worse? Don't really know. Blah. It's going to be a lot more. It's going to come to the forefront a lot quicker now to be able to see the improvements, or equally the when it gets worse. So yeah. As I say, this week I want to try and concentrate on see if I can write a tool to basically capture tracks, so you can draw your mouse around and it'll capture the movement you make.
Oh, cool.
And then, yeah, the idea is then because can I share my screen again quickly?
Of course.
Yeah.
Sorry. I just want to show you guys. So this essentially is I don't know if let me know if you can, when you can see. Can you guys see?
Not yet.
Yeah.
Yeah.
Or not yet? Okay.
Yeah.
So this basically is the path that the object takes. So first of all, that's the frame size that was in play when the path was captured, because I need that in order to scale for different frame sizes. And this over here is for the plane. So in order to plug additional ones of these into the tests, I would like to be able to produce this path sort of thing.
You
And
should
that
ask,
would be
I forgot his name, to create it in the simulation. That should be easy.
Matt.
Hey, Mike,
Matt,
I have a
yeah,
question
Matt.
for you. Hey, Mike.
Sure.
How you generate this path for the object?
Mouse.
Yeah, so those were done by me putting together a bit of code and dumping out the track of an existing video. But I would like to create a tool that I can use to generate the path, and then that other people can also use to create a path if they have a certain path that they want to test. They run the tool, capture the path, that produces that sort of matrix. They then just copy and paste that into a class and plug it into the tests, and off they go. I would like to make that process as easy as possible, because I think that would allow people to run tests quite quickly and ultimately produce or highlight problems which would be better to know earlier than later, sort of thing. So yeah, the next thing on the to-do list is to write a tool so that you can use your mouse to draw a path around a screen, which it will then capture and give to you, that you can then use to plug into the simulation. So this stuff is separate to what Matt's doing currently. So I think this is just really Billy Basic sort of. I see it as just really Billy Basic sort of simulation, just chasing an object around a white screen. But we'll just see where it goes from there. I think it's a reasonably good start. So, and that's it. Thanks, guys.
Thank you, Mike. Absolutely.
Amazing.
The idea to simulate and to test algorithms is a great one. Of course, you can tweak it to all kind of inputs then from light sources, for example, from light situations, to tweak it towards night situations compared to day situations or weather situations.
Yeah, I think that might be
Software
a
is
bit.
able to distinguish the light source, moving light source, not only black point.
Yeah, so I think that's more
Indoor.
akin to the stuff that Matt's working on.
Okay.
In all fairness, so I think the tools that he's using, I do have a book on it, which I've given Richard the PDF as well to upload. But that's probably outside of my wheelhouse for what I have, what I'm able to do. So the only thing I can really do to improve on what I currently have is to use frames from a video and overlay our objects on that. So that doesn't necessarily mean that that video has to be something that's taken. That video could be something that is generated using Unity and a simulation, and then we can plug into that video, which will essentially achieve the same. So it's basically a combination of those two sets of tools, really.
Yeah. You need to create a video. Matt knows that, but you need to create layers in the video, right? So you have the sky layer, you have the probably space layer even, clouds, geysers. It needs to create all of this.
Yeah, I think that's a fair point. I mean, I think it's on the to-do list somewhere.
Yeah.
We'll get there. We'll get there. Eventually.
There are known layers. It's I'm just not in the field anymore. So.
Okay.
Yeah, and if we go really for a simulation material, that simulation should also be able to simulate a real fisheye. What I just saw is it was a 120 degrees optic that he simulated, and what I saw is that this simulation was a bit off for me because it was concentrated around the rim in the middle and not evenly distributed like I would expect a certain focal optic would have. So what I want to say is that maybe there's a little bit of tweaking necessary on Unity to get a real fisheye. Not just increasing the hemisphere to 180, because that, yeah.
You want to bend the video to a fisheye? Oof.
Now, yeah, we should simulate. I mean, if we talk about simulation and the material that the tracker shall run on, then it should be as close as the reality as it is.
Yeah.
Okay. Guys, any more to this topic? Because the hour is...
C'est mes collègues sur lesquels on travaille là-dessus. Tous les dimanches soirs, on se réunit à 6h. Non, mais c'est pas grave. Enfin, ça dure 2 heures, je verrai après. Je vais juste mettre un petit mot pour dire que...
I have to mute him, sorry. I had to mute him. He couldn't hear me. Guys, it is 1 hour. I say we stop the recording for now. Developer meeting is, sorry to say, over for today because we're stepping over to a different channel because we have an internal discussion about ethics and how we deal with situations that we had, let's say, a couple of days before. And that's why I stopped recording.